Okay, continuing on here in lesson 5.9. We're going to define a complex number. We've been working with the imaginary unit, imaginary numbers, but a complex number is any number that can be written in the form a plus bi. So a plus bi, where a and b are real numbers and I is the imaginary unit. A is called the real part. In other words, this is the real part because it doesn't have the I on it, and b is the imaginary part. So for instance, 7 plus 4i is the example they give. 7 is the real part, or the non-I term part. 4i, or 4, is the imaginary part. Okay? Or they give 2 minus 6i, so 2 is the real part. Negative 6 is the imaginary part, or negative 6i is the imaginary part. So the term that has I on its imaginary part, the other part's the real part. We always, when we write complex numbers, put the I term last. You want the real part first, the I term last. That's kind of, usually if you have 4 plus 2x, we've been taught to write it 2x plus 4, put your variable part first. Well, if I have 4 plus 2i, that's the way you want to write it, with the non-I part first. So it's kind of a little bit different algebraically than it is algebraically. Okay? So, let's go in and look at an example here. Find the values of x and y that make this equation true. You have 2x plus yi equals negative 14 minus 3i. This right here is the real part. This is the real part here. So you want to set the real parts equal to each other and solve. Okay, so if we do that, we're going to set 2x equal to negative 14. And so we're solving for x here. So if I solve that for x, I divide both sides by 2, I get x equals negative 7. Negative 14 divided by 2. Okay? You also want to then solve for y. So I have yi. So we want to set the imaginary parts equal to each other and solve. Okay, so I really have y, okay, is equal to negative 3. Now I don't really need to put the I on there, just what's in front of I. So all I have is the y in front of the I on the left side, and I have the negative 3. Now, I say and solve, well this is already solved. Sometimes you might have to do a division like we had to do when we solved for x, but in this case, y has to be equal to negative 3. And that's it. You're just finding x and y. Okay? Now, when you are adding and subtracting complex numbers, all algebraic rules apply. All the algebraic rules apply that you've learned since algebra, the beginning of algebra. Okay, so if I have 3 plus 5i in parentheses and I'm adding 2 minus 4i, remember a plus sign here doesn't change any of the signs. So I can really just drop off parentheses, so it's 3 plus 5i. Okay, so this sign right here keeps the 2 positive and the 4i negative. We'll deal with what happens when it's a minus sign on the next problem. And then all I do is combine like terms. Okay, and we want to write them as a complex number, so we want to put our non-imaginary parts first. So 3 plus 2 would be 5, and then I want to combine my I parts, or my imaginary parts, would be plus 1i. Okay, so I'm going to write that as just 5 plus I then. Now, I plus 5 is acceptable, but we usually put the non-I term first, the I term second, so that it's a complex number. So that would be 5 plus I. When you get here and it's subtraction, just remember you got to carry the opposite sign through. The signs in the 4 minus 6i in that first set of parentheses don't change, but this will become minus 3 and then plus 7i. So you're distributing your opposite sign through. And now you just combine like terms again. Let's combine our non-I parts first. 4 minus 3 is 1. Negative 6i plus 7i is plus 1i. So really I have 1 plus I for that complex number answer. Okay, now we'll get into multiplying and eventually dividing here. If you multiply, this is like a binomial times a binomial, you FOIL, just like you would algebraically. I got done saying all the algebraic rules apply, that's what we're going to do. So we're going to FOIL, because we're multiplying in between. So I'm going to multiply my first terms, that's 7. My outside terms, 1 times negative 5i, is negative 5i. My inside terms, 3i times 7, both positive, would be plus 21i. My last terms, positive 3i times negative 5i is negative 15i squared. Okay? Now, we have to remember what I squared is equal to. It is equal to negative 1. So I really have 7 minus 5i plus 21i. And then if I do minus 15 times a negative 1, that would be minus a negative 15, or is going to turn that to plus 15. So in that step, I changed my I squared to negative 1. Now I want to combine my real parts, which are my non-I terms. So that would be 22. They're both positive. And then I want to put my I terms together. So that negative 5 plus 21 would be plus 16i. So it's 22 plus 16i. Now, I don't have an example in the notes, but I just want to go through one thing here. If I have 2i multiplied by 3 minus 6i, so it's a monomial 2i times the binomial 3 minus 6i. All the algebraic rules apply, you would just distribute. So this is just giving you another example. 2i times 3 is 6i. 2i times negative 6i is negative 12i squared. But remember, I squared is negative 1. So this really is 6i minus a negative 12 or plus 12. Would be acceptable to write it that way, but it's best to put your non-I term first. So it'd be 12, and your I term second. So it'd be 12 plus 6i. So this is just one where you have a monomial, then you wouldn't FOIL, you would just distribute. Just to give you another example. So write that one down if you need to. All right, dividing complex numbers. You must rationalize the denominator. Can't have I in denominator. We are going to rationalize. It's just like you can't have a root or a fractional exponent there. Okay? Things are not simplified if you have i's in the denominator. Now, we're going to use some of those same rules that we used earlier to rationalize ones with dealing with roots here. Notice in the denominator right here, I have 3 plus 2i. Remember when we talked about the conjugate? Okay? So we want to multiply by the conjugate, and you'll see why here in a second. So the conjugate, like we talked about in previous lessons, would be, the sign in the middle would be different. Then on the top, I want to multiply by 3 minus 2i. Okay, so on the bottom, this is why we multiply by the conjugate. You're going to see that the i's disappear. I'm going to do 3, I got a FOIL, so 3 times 3 is 9. Now, I'm not going to do my outside and inside. This is why we're multiplying by the conjugate, but minus 6i plus 6i would drop out. It would be 0i. Okay, then I get 2i times negative 2i, which is negative 4i squared. But we have to remember that I squared right there is negative 1. So on the bottom, I'm really going to have 9 minus a negative 4 when I multiply 4 times negative 1, or 9 plus 4. So that right there, and we'll simplify that in a little bit to 13 here. But let's do the top. Now on the top, I have a monomial times a binomial, so I need to distribute. So I get 15i, 5i times 3, minus 10i squared. Actually, let's take and write that on the one above it, and then we'll do some simplifying. So let's rewrite that. That's 15i minus 10i squared. But remember, I squared is negative 1. So I really have 15i minus a negative 10 or plus 10. Okay, so let's simplify this a little further. And I'm actually going to put my real part first, so I'm going to write the top as 10 plus 15i. We like to have the non-I part first, over 13. Now, with these, there's some different ways you can write the answers. You have to make sure you check to see if you can reduce, like you could with radicals. If there is a common factor of all three of these, you would need to reduce it. Notice 13 does not have a common factor with 10 and 15, so we can't reduce that. Okay, so you could just leave your answer as 10 plus 15i over 13. But if we wanted to write it as a complex number, really that's 10, or this, over 13, plus this, which would be 15/13 I. So this, or again, you could leave it as 10 plus 5i over 13. That would be acceptable. Just make sure you reduce it if you can, if you leave it like that. Okay, let's look at the last one here. Now notice I don't have a binomial on the bottom. I don't have a plus or a minus on the bottom. So I don't have to multiply by the conjugate here. Okay, I want to multiply on the bottom here by I, because if I do that, I'm going to get 5i squared. Well, I squared is going to be negative 1, which is going to get rid of my I on the bottom. If it was 5 plus I, yes, then you'd have to multiply by the conjugate of 5 minus I. Now, if I do that on the bottom, I have to do it on the top as well. And we're going to distribute up there. So I have 4i minus I squared. Okay, let's simplify this a little bit. Remember, this is negative 1. So I really have 4i minus a negative 1 or plus 1. On the bottom, I have 5. Well, I had 5 times I squared, but I squared is negative 1, so I have 5 times negative 1, which is negative 5. Okay, I'm going to do a little rearranging. You can't simplify that any. This would be an acceptable answer, but there's probably a better way to write it. Okay, I am going to put my I term second on top, so I'm going to write it as 1 plus 4i over negative 5, and now I'm going to kind of pull it apart, each part. So I have negative 1/5, or 1 over negative 5, plus 4 negative 4/5 I. Okay, now instead of writing plus negative right there, you could write it as this, which would probably be the best way. Negative 1/5 minus 4/5 I. Okay? Now, any one of these would be acceptable and is okay. Probably this one where we have our I term second as opposed to our I term first on the top one there.